A second tailwind that all of engineering is experiencing is the drive to be more sustainable and carbon neutral.
Yes.
Where is material science? How is material science feeling that tailwind?
Very much. Very much. I think it's one of the big drivers currently of our science. Maybe it has always been, but it was not so well visible. Yeah, and people got crazy and then said, doesn't matter if we make a complete airplane motor out of platinum alloys because it's a little bit more efficient. Let's make it out of platinum. This is, of course, not a good way to do it. No? So, but sustainability was always in the focus, and it becomes more. And you see it, for example. I take my own example. We were Max Planck Institute for Research on Iron and Steels and so on, and we decided to change our name to Max Planck Institute for Sustainable Materials. And one reason is iron and steel is one of the big drivers of carbon dioxide emission. Yes. 10% of all worldwide carbon dioxide emissions is actually created by the steel production. It doesn't matter whether the carbon dioxide is finally responsible really for changing our climate, but it is anyway important to have a sustainable use of our resources. Yeah? If we burn all oil and all coal, maybe it will heat up the atmosphere, but definitely the oil and coal will be gone. That is one important thing. So I have always been in favor, let's find ways to make that in a sustainable way, and sustainable means energy which is coming in will come in from an unlimited resource like the sun.
So you need a circularity to the process.
Yes, and you can do this for steels by using hydrogen, and the hydrogen you have produced from solar energy. Yeah, and what do you need to produce hydrogen from solar energy? You need a solar cell, or you need a special reactor which uses the thermal energy of the solar sun to split water into oxygen and hydrogen, and then you get free hydrogen and can use this. So that's one thing, and then you can study how hydrogen can be used to reduce iron ore to iron. But you can also you need also to care. Let's say hydrogen will be the future carrier of energy for our society, but hydrogen is a very detrimental element for many materials. It creeps into every steel, it creeps into every metal, into every material, and weakens it usually. Yeah. So what happens there is an important topic to be studied by material science. Then you think about the other storage of energy. It's electricity, batteries. Battery is really a sustainable way of storing and providing energies, but we are by far not efficient enough. Yeah? You need to understand how do these arrangements of a cathode and an anode and an electrolyte, how do they electrically and microstructurally interact? And how do they degrade over the life of a battery? Yeah, you see your laptop battery after 3 years of use, it has half the capacity as it had before. What happens there inside? It's all material science. It's more material science than we think. Yeah, it's not chemistry only; it's materials. No, and many examples can be given like that. No? You mentioned earlier recycling. Yeah, that's also a very important part of making our world sustainable. You collect all the cars which have been thrown away and you melt a fresh steel out of it. But the problem is, these cars are not created only out of one steel quality, but of several. And they are not only steel, but there's also an electrical motor which contains copper. It all goes into the same pot and is molten away. You have suddenly copper in your steel. You don't want that. So how do you deal with that? Yeah, how can you make a new material although it contains copper? We find solutions, and this is all pure material science. Yeah, and this is for many other materials the same way. So sustainability is a very big thing in material science.